Here we're asked to graph the function by graphing its parent function and applying the transformations. So I'm going to use my h and my k value to kind of give me my first x and y value for this one here. The first one is going to be 3 over to the right and 2 up. So that's kind of what we call my turning point. And then I kind of use the points around it to help me graph the rest of it. So I'm not going to write out the math, but if I were to plug in 4 minus 3 is 1, 1 cubed is 1, plus 2 is 3. If I were to plug in 2, 2 minus 3 is negative 1, negative 1 cubed is negative 1, plus 2 is 1. If I were to plug in 5, 5 minus 3 is 2, 2 cubed is 8, 8 plus 2 is 10. And if I plugged in 1, 1 minus 3 is negative 2, negative 2 cubed is negative 8, plus 2 is negative 6. So 1, 2, 3, 4, 5. And so my cubic function should look a little something like this with those x and y values. Second one here, same idea. I'm going to use the transformations to help me. So I'm going to use my h and my k value to help me start it out. That means that I'm going to go 2 to the left and then also 2 down, and then plug in some points around it. So if I plug in negative 1 plus 2 is 1, 1 cubed is still 1, times negative 3 is negative 3, minus 2 is negative 5. 1, 2, 3, 4, and 5. If I were to plug in negative 3, that would be negative 3 plus 2 is negative 1, cubed is negative 1, times negative 3 is positive 3, minus 2, which is just positive 1. Now, I could plug in some more numbers here, but I know that they're going to kind of go off the graph here because of this stretch. So I know I'm going to go ahead and do this. Call this my cubic function here. Again, what we would plug in basically is 0 and negative 4. And then we would get really big numbers that go off of our graph here. So here's my 3 reference points that I was asked about in the original question for both of my graphs.